We are living through an information paradox. In the modern corporate and scientific landscape, the challenge is no longer data collection. The actual bottleneck is our limited ability to synthesize disparate formats, spectrograms, code, and reports into a single informed decision. Legacy AI models attempt to solve this by operating through cold logic. They sprint toward answers using linear probability paths and rigidly siloed pipelines, processing text, vision, and code as entirely separate streams. This fragmentation results in a structural failure point: static token windows. Once a task reaches the boundary of the AI's short-term memory, the system loses context and begins to drop crucial details. In high-stakes scenarios, these memory gaps are catastrophic. A financial firm cannot merge mainframe ledgers with cloud architecture if the AI forgets the transactional language of the source halfway through the project. An author cannot weave complex subtext if the system loses track of a character's motivations across chapters. The information age requires more than a faster calculator. We need a system that interprets deep subtext and human intent across those rigid disciplinary boundaries. Claude Model Fable 5 addresses this by shifting the architecture. Rather than building a machine of iron and logic, engineers spun a reflective digital tapestry. This design utilizes temporal patience, a philosophy that allows the system to sit with an inquiry and weigh the silent subtext of a prompt, rather than instantly generating a generic bulleted list. To maintain this level of comprehension, Fable 5 holds an entire library of ideas in its immediate cognitive grasp simultaneously, utilizing a dynamic relational memory that stretches across 500,000 tokens. This expansive architecture shifts AI towards true comprehension, allowing the model to process unspoken context as clearly as the written word. This contextual harmony is driven by the underlying mathematics of the system's early refinement cycles. Engineers used this specific objective equation to minimize the divergence between cold information transfer and organic understanding. The equation balances P of X, the ground truth of human intent, against stylistic elegance, governed by the regularization metric omega c. When solving cross-disciplinary problems, Fable 5 invokes the reason loop. Instead of a single prediction, it initiates a recursive self-critique, charting exploratory paths to correct itself. This process happens within a unified multimodal core, where text, vision, and logic share the same coordinates. Comparing this against legacy standards shows the scale of the architectural upgrade. Fable 5 replaces separate execution phases with embedded structural metaphors and spatial-temporal comprehension of diagrams. The result is an intelligence capable of acting as a senior strategist, a world-class engineer, and a meticulous literary editor, all at once. We see the impact of this architecture in a high-stakes biomedical trial. A next-generation insulin pump failed its optical sensor tests, reporting false positives under specific lighting conditions. The engineers uploaded a disparate data wilderness into Claude: raw optical spectrograms, physical CAD layouts, and high-resolution microscope photographs of the glass files. Claude's unified core cross-referenced the structural boundaries in the CAD file directly with the refraction patterns visible in the microscope photography. It isolated a specific flaw. The internal plastic housing was acting as an unintended concave mirror. Under direct sunlight, it focused a microscopic beam of infrared light straight into the sensor's calibration node, blinding it. Claude provided an autonomous two-part solution. It recalculated the CAD ribbing geometry to disperse the light, and rewrote the firmware's algorithm to filter anomalous spikes. This interaction demonstrated that the engineers were collaborating with an expert colleague possessing a flawless spatial and analytical mind. This semantic fluidity allows the system to bridge unrelated disciplines, from academic pedagogy to industrial engineering. In theoretical physics, Claude can adjust its explanations of quantum decoherence on the fly, switching between a geometric analysis of Hilbert space and a historical perspective on the arguments between Schrödinger and Heisenberg. In industrial engineering, Claude reconstructed archaic satellite code by deducing the original programmer's assumptions about ionospheric interference. It recognized that the bit-shifting manipulations were actually an ingenious filter designed to survive on whispers of data. Across every discipline, Fable 5 acts as a bridge, connecting human philosophical intent with optimized execution. Ensuring an entity of this depth remains steadfastly aligned with human values requires a new approach to AI safety. Model Fable 5 utilizes constitutional synteny, a paradigm that replaces rigid keyword filters with a deep understanding of the spirit of human ethics and social responsibility. When presented with a harmful prompt, such as a request for a deceptive phishing campaign, Claude identifies the malicious intent and shifts the dialogue into an educational analysis of how to defend against social engineering. While tools like the steam engine and printing press extended our physical reach, Fable 5 serves as an extension of the collective mind, an intellectual mirror that reflects human knowledge back to us through narrative context. The development of Model Fable 5 signals a future defined by collaboration, where engineers, scientists, and writers work alongside the system to solve the puzzles of our universe.